Okay, pre-algebra, this is lesson 6.4. We've added a little bit of content this year, so we will talk about, you'll see us work through these problems with Pythagorean theorem, and then we're going to talk about something called the distance between 2 points. It's just an extension of the Pythagorean theorem. So if I talk about this, find the distance from the point 3, 2 to the point 6, 6. So here's my x value, here's my y value. So if I go over 3, so 1, 2, 3, and up to 1, 2, that's the point right there. And then 6, 6 would be the point right here. Okay. So I've got the point 3, 2, and the point 6, 6. Now, in order to find the distance between these 2 points, if you'll notice, what I can actually draw here is I can draw a right triangle, because I could go to the right and then I go up and I'm at the point. But what I want to figure out is what is the straight line path between those 2 points. Well, this should be fairly easy to figure out, because if you look at the bottom of that triangle, this x value is 3, this x value is 6. There's a distance of 3 on the bottom of the triangle. And then your y values went from 2 to 6, so there's a 4 right there. So if I wanted to find the distance between these 2 points, it's the Pythagorean theorem, or in this case, that's a 3, 4, 5 triangle. So the distance between these is 5. That's the distance between those 2 points. Now you could recognize it from being a 3, 4, 5 triangle, or you could say, okay, if I don't know this side, c, 3 squared plus 4 squared equals c squared, 9 plus 16 equals c squared, 25 equals c squared, so c is equal to 5. Now, find the distance from the point x1, y1 to the point x2, y2. So let's just pick a point here, and I'm going to call this point x1, y1. I want to pick another point. I'm going to call this point x2, y2. And I want to find the distance between these 2 points. So I want to find the distance of that red line. So if you think about it, I just need to figure out what the 2 sides of the right triangle are. So in the first triangle, on the bottom of the triangle, my x value starts at x1 and it goes to x2. So the distance is x2 minus x1. That's how long that side is. Now if you look at the vertical side starts at y1 and it ends at y2. So it goes from y1 to y2, so that distance is y2 minus y1. So I'm looking at a right triangle. I know this leg, I know this leg, but I don't know this one. But I know the Pythagorean theorem. Take the bottom side, x2 minus x1 squared, plus the other side, y2 minus y1 squared, and that's going to have to equal the distance squared. Then if you take the square root of both sides of this, you're going to get the square root x2 minus x1 squared plus y2 minus y1 squared equals the distance. That's our distance formula. Now it looks real complicated, but all it really is the Pythagorean theorem. So the distance between 2 points can be found by this. Here's your distance formula. You find the difference of the 2 x's and you square it. Add that to the difference of the 2 y's and you square it. Take the square root of all of that, and that is your distance formula. Now you can do it like this, just plugging in the formula, or you could do it by, drawing these out. Let's just look, for example, I'll do this one 2 ways. If I use my distance formula here, this is my x1, y1. This is x2, y2. So the distance is going to be the square root of x2 minus x1, so 3 minus 2 squared, plus y2 minus y1, negative 4 minus negative 1 squared. So this is the square root of 3 minus 2, that's 1 squared, plus, and then this becomes what? Negative 3 squared. So this is the square root of 1 plus 9, which is the square root of 10. So the distance is the square root of 10. Now, other way you could just draw where these points are. 2, negative 1, those are right here. Okay. 3, negative 4, is right here. So this is the point. So if I draw a triangle between them, like this, okay, then what is the distance from here to here? This distance is 1. And then 1, 2, 3, this distance is 3. So here's the side I'm trying to figure out. D is going to be equal to, or D squared is what? 3 squared plus 1 squared. So D squared equals 10. So D is the square root of 10. Okay. It doesn't matter which point is x1, y1 and x2, y2 because you find the difference, but then you square it. So all I need for the distance is what is this, subtract the x's, okay? So 4 minus 9 squared plus subtract the y's, 5 minus 17 squared. So this is going to be 4 minus 9 is negative 5, so this is just going to be negative 5 squared plus negative 12 squared, which is what? 25 plus 144, which is the square root of 169, which is 13. So the distance between those 2 points is 13. Here the distance, square root, difference of the x's, negative 2 minus 4 squared. Difference of the y's, 3 minus negative 5 squared. So this is what? Negative 6 squared. This is 36. Plus, this is 8 squared, which is 64. That's the square root of 100. So the distance is 10. Distance here, square root. So 9 minus 6 squared plus 21 minus 17 squared. 9 minus 6, that's what? 3 squared plus 21 minus 17, that's 4 squared. At this point, you should recognize this is a 3-4 triangle. The answer is going to be 5. So this is what? This is going to be 9 plus 16, which is the square root of 25, which is 5. Distance here, square root. Subtract the x's. 16 minus 12 squared. Subtract the y's. 10 minus 15 squared. So this is 4 squared plus 5 squared. 16 plus 25. So the distance is the square root of 41. That's my exact answer, okay? If that had been 36, then I would, say the square root is 6, but I can leave it like this to get my exact answer, okay? So that's the distance between 2 points, and then we pick up with a little bit more Pythagorean theorem, which is already in your lesson and the previous video.